Every year, 1.5 million engineers graduate from Indian universities. These minds flow outward, embedding themselves within every major tech corporation on Earth. At Google, the ultimate direction of the company is dictated by Sundar Pichai. Over at Microsoft, Satya Nadella guides the strategy of a $3 trillion empire. Yet the algorithms that are actively rewriting the global economy, systems like ChatGPT and DeepSeek, did not emerge from Bengaluru or Hyderabad. They came out of San Francisco and Beijing. The country supplying the intellectual engine for the world's tech infrastructure has not produced its own globally competitive foundational AI model. As a result, 1.4 billion people are currently positioned at the end of the supply chain. They are downloading, prompting, and paying for artificial intelligence, rather than inventing it. Raw technical talent is a necessary resource, but alone it does not guarantee a nation control over the next technological frontier. In the late 1990s, the global panic surrounding the Y2K bug presented a highly lucrative opportunity. Indian programmers stepped in to fix the world's code, rapidly scaling an IT export industry that soon crossed billions of dollars. That early success established a highly specific corporate culture. The industry optimized for execution, maintaining, testing, and debugging software built by others. It rewarded strict adherence to client specifications, entirely bypassing the messy, unpredictable process of inventing completely new technologies. Across the Pacific, the approach is reversed. Institutions like Stanford University operate as research powerhouses, heavily funded by government agencies and private capital, explicitly designed to take massive risks on experimental, long-term projects. Back in India, the academic pipeline prioritizes a different skill set entirely. To gain entry into elite institutions, students must perfect rote memorization. The system strictly rewards the correct answer on a standardized test and heavily penalizes failure. This environment fosters jugaad, a cultural philosophy of finding quick, makeshift workarounds. While highly effective for optimizing a service delivery model, it collapses when applied to the methodical, multi-year mathematical research required to train large neural networks. An educational and corporate pipeline built to reliably produce compliant, efficient problem solvers cannot spontaneously generate the kind of disruptive researchers needed to build AI from the ground up. Brain drain represents a systematic extraction of the specific mathematical and engineering talent needed to sustain a domestic AI industry. This flow diagram tracks the annual movement of technical talent. Nearly 800,000 individuals leave India for foreign universities each year. Notice how the vast majority, 70% of this outbound flow, establishes permanent roots abroad, with only a fraction ever returning home. The incentives are completely lopsided. A promising AI researcher arriving in the US can secure massive seed funding in a single meeting and access state-of-the-art server clusters within days. In India, researchers face months of bureaucratic delays just to procure basic laboratory equipment. Ultimately, these exported minds concentrate in places like San Francisco and Santa Clara, forming the intellectual backbone of the world's most dominant AI labs. Through this continuous, unfiltered pipeline, India actively subsidizes the research and development talent pool of its most powerful geopolitical competitors. But human capital is only one variable in the equation. Training advanced AI requires a massive foundation of raw physical resources, vast datasets, and immense computing power. In Beijing, the government treats data as a strictly controlled national asset. By utilizing the digital footprints of 1.4 billion citizens without stringent privacy restrictions, they have amassed a highly effective training ground for their own AI models. Then there is the hardware constraint. Processing that data requires thousands of highly specialized graphics processing units working in tandem. Currently, the local infrastructure lacks the dense, high-performance GPU clusters necessary to compete at a global scale. Looking at the financial side, this bar chart breaks down AI startup funding for 2023. The discrepancy is immediate. The U.S. market deployed $67 billion into the sector, while India received roughly $1.5 billion. It's also a matter of velocity. Indian venture capitalists strongly prefer immediate returns from consumer apps and e-commerce platforms. They are highly reluctant to fund 10-year deep tech research cycles, leaving domestic AI founders waiting for capital that consistently stalls before it arrives. Without sovereign computing infrastructure and patient capital willing to tolerate long-term risk, even the most elegant mathematical algorithms remain trapped on the whiteboard. Despite entering the race late, the trajectory is beginning to shift. A distinctly new strategy is taking shape outside the traditional tech hubs. The country possesses a highly unique, structurally complex dataset that no other nation can replicate. There are 22 official languages and over 1,600 distinct dialects actively spoken across the subcontinent. This pie chart maps the global linguistic landscape. While Western companies compete aggressively over the English-speaking slice, a massive demographic of 2.5 billion non-English speakers remains completely underserved, representing an open monopoly for native multilingual AI models. There is already a proven blueprint for scaling technology to this specific population. The country previously digitized its entire economy by rolling out universal public systems like the UPI payment network. That same mass distribution architecture can be adapted to deliver AI directly to rural populations. There is also a severe difference in overhead. A highly specialized research team can be assembled and fully funded in India for a fraction of the operating cost required in Silicon Valley. Artificial intelligence derives its greatest utility from the optimization of physical systems, solving the fragmented logistics of agriculture or the diagnostics of remote healthcare in environments where Western models lack local context. Overcoming the structural deficit in compute and capital remains the primary hurdle. However, if that infrastructure is built, India's internal complexity transitions from a liability into a unique strategic asset, one that could finally turn the nation from an exporter of brains into an architect of intelligence.